Hey everyone, when we talk about SQL, we usually think about just storing and grabbing data, right? But what if your database could be smarter? Today, we're going to pull back the curtain on two of SQL's secret weapons, triggers and views. These are the tools that make your database more responsive, more secure, and honestly, just a whole lot more intelligent.
So let's start with this big idea. What if your database could actually think for itself? I mean, really think. What if it wasn't just this, passive box where you dump information? What if it could actively stand guard over your data, enforce some really complex rules, and react to changes all on its own?
And that's really the core concept we're digging into today. We're talking about a major shift from a passive database that just kind of sits there holding data to an active one. An active database has intelligence baked right in. It's always watching, it's checking things, and it's taking action. It becomes this powerful, automated guardian of your data's integrity.
Okay, so how do we actually build this active database? Well, our first tool is something called a trigger. The best way to think about it, it's like a reflex, a pre-programmed response that the database just does automatically when something specific happens. It is the ultimate if this, then that for your data.
All right, here's the official definition, but let's make it simple. A trigger is just a rule that automatically kicks off an action when a specific event happens in the database. The two magic words there are automatically and event. You set the rule up just one time, and the database handles the rest. It's tirelessly monitoring for that event to happen. Now this slide here, this is the simple but super powerful logic behind every single trigger out there. It's called the event condition action model. First, an event happens, say someone updates a row. Then the database checks a condition that you've set up, and if that condition is true, boom, it performs the action. Event, condition, action. Get that down and you've got the DNA of every trigger.
Okay, let's make this real. Let's imagine we have this social group in our database called the Cool Kids, or KICS for short. And we want to set a rule. If a member's popularity score gets updated and it drops below 0.5, they get kicked out of the group automatically. This trigger right here does exactly that. Now let's break down how this piece of code actually works, using that event condition action model we just talked about.
First up, the event. You can see it highlighted right there. The trigger is set to fire after the pop column, that's for popularity, gets updated on the user table. That's our very specific trigger event. Not just any update, an update to that column. Next, we have the condition. So after the event fires, the trigger checks two things. First, is the user's new popularity score less than 0.5? And second, are they currently a member of the clicks group? Super important. Both of these things have to be true for the trigger to keep going.
And finally, the action. If that event happens and both of those conditions are met, the database just automatically runs this command to delete that user from the member table for the racks group. And just like that, they're out of the club. No human intervention, no manual work needed. It just happens.
Okay, so triggers give our database reflexes. That's pretty cool. But our next secret weapon, views, gives us these custom windows into our data. And this really builds on that idea of making our whole system smarter and way more accessible for people to use.
So you might be asking, why even bother with a view? Well, there are three huge reasons. First, they hide complexity. You can take a really messy, complicated query and package it up so it looks like a single simple table to everyone else. Second, security. This is a big one. You can create a view that only shows certain columns, hiding sensitive data like salaries or personal info. And third, they create a stable interface. This means you can go change the real tables in the background, and as long as the view stays the same, the apps that use it will never know the difference. No broken code.
And to really see why this is so important, just imagine a user who needs some info on our Cool Kids group. The actual query to get that data might look like this. A bunch of joins, complex logic. It's not impossible to write, but it's clunky, it's error-prone, and you definitely don't want every single person on your team having to write this thing over and over again.
And this is the solution. It's so elegant. We use the create view command. We take that big, ugly query from before, we give it a simple, friendly name, in this case, Cool Kids, and we essentially save that query as a virtual table in the database. All that complexity is now hidden away, tucked neatly under one simple name.
And here it is, the payoff. Now, if we want to find the average popularity of the Cool Kids, we don't need that monster query anymore. We just write this beautifully simple line. We're querying our Cool Kids view just like it was a real table. It's clean, it's intuitive, and it just works. That's the power of abstraction.
Okay, so this leads to a really fascinating question. We know views are virtual, right? They don't actually store any data themselves. So can you change them? Can you actually insert, update, or delete from a virtual table? Well, the answer is it's a bit more interesting than you might think.
Let me throw a little puzzle at you. Let's say you have a view called popular user, and its only rule is where pop greater than 0.8. It only shows you the really popular users. Now, what do you think happens if you try to insert a brand new user with a popularity of, say, 0.3 into that view?
The simple and maybe surprising answer is you can't. In most database systems, that's just going to fail. And it makes sense if you think about it, right? It's a logical contradiction. How can you add something to a list when the very item you're adding doesn't meet the criteria to be on that list in the first place? The database just says, nope, can't do that, and rejects it.
And this is where our two secret weapons, triggers and views, come together perfectly. The solution is a special kind of trigger called an instead of trigger. When you try to modify a view that's too complex, this trigger basically hijacks the command. So instead of just failing, it runs your custom code instead, letting you intelligently update the real tables underneath. It gives you, the developer, complete and total control over what happens.
Now, as you can imagine, with all this incredible automated power comes some responsibility. Triggers are amazing, but if you're not careful, they can also introduce some pretty tricky problems into your system.
The biggest one, the one you really have to watch out for, is recursion. Just imagine this. Trigger A makes a change that fires trigger B, but then trigger B makes a change that fires trigger A all over again. You see the problem? You've just created an infinite loop that can absolutely bring your database to its knees. You have to plan out these interactions very, very carefully.
And listen, don't think for a second that these are just some obscure academic features that nobody uses. As the source material for this whole explainer states directly, and I'm quoting here, real database applications use tons of views. They are an absolute cornerstone of professional, robust, and secure database design. This is real-world stuff.
Which kind of leaves us with one final thought. By giving our databases these reflexes with triggers and these custom windows with views, we're building systems that are more automated, more intelligent. So the real question is, how far can we actually push this? Are we on a path toward databases that can truly manage themselves, protect themselves, and maybe even heal themselves? That's the future that tools like these are helping to build.